Okay, welcome back to another gas law here. We just did combined gas law in the previous video. This is the ideal gas law. The ideal gas law is a law that allows us to calculate for pressure, volume, how much gas, the number of moles, and the temperature of a gas. If we know we know three, then we can find the last one. Okay, the ideal gas law. The word ideal means in a perfect situation for a perfect gas, which doesn't really exist, but theoretically speaking, we can do that. And we can use this as a model to predict how gases behave and how many gases there are, how many gas molecules there are, what the pressure is, what the volume is, and what the temperature is. Just like an estimation, okay, in terms of how gas really do behave. Ideal gas law is as follows. The equation is PV equals nRT. All right. P is pressure. And to use this law, it has to be an atmosphere, ATM. So whatever unit of pressure it is, you need to change it to atmosphere. Volume is V. It has to be in liters. Must be in liters. You have to change it to liters because of the R. This R tells us exactly what units the other must be. N is the number of moles. Like how many moles of hydrogen gas, how many moles of oxygen gas, how many moles of any gas, really, just the number of moles. T is temperature. It has to be in Kelvin, okay? So, again, atmosphere, liters, and Kelvin. If it's not in those units, you have to change it to that unit. And we've done that. You should be very familiar with that by now. Then R is a ideal gas constant, which is 0.0821, and that's the number you use. You don't round this, okay? That number is already rounded. And the unit for this, let me check on this unit again. Here it is. ATM liter mole K. ATM liter mole K. It's a weird unit, and you don't need to put the units whenever you write this down. Just as long as that tells you what the pressure for unit must be. ATM, volume, liters, moles, and Kelvin temperature. Okay, they have to match. So each of these, you just list out: P, V, N, R, T. R is a constant. I forgot to tell you, this is a constant. So it's always that number. So R is 0.0821 automatically. R for the next one is 0.0821. R for any of them is 0.0821. All right. So 0.023 moles. And that's N. 0.0800. I'm sorry, 23. Dang it. Messed up on the decimal place here. 0.03. 0.023 moles. Okay. 4 liter container. So what's that? The liter is the volume. 4.2 liters. And temperature is 20 degrees Celsius. And we need to change it to Kelvin by adding 273. That's 293 Kelvin. So I said, what would the pressure be? Okay, so pressures are X. There. So we have PV equals nRT. Okay, and so P is what we're looking for. V is 4.2. Equals N, which is 0.023, times R, 0.0821, times T, which is 293. So how do I get P by itself? And to get P by itself, we divide both sides by 4.2. And that'll go away. P is equal to, punch all that into your calculator. One operation, ladies and gentlemen. I still see a lot of you hit enter between each operation. And no, you don't do that. That's just more work. 0.023 times 0.0821 times 293 divided by 4.2. And there's my pressure. Pressure is 0.13 ATM. With these 2 decimal places is good. Okay? Like that. And look, the answer's there. Must be nice. We can check our work as we do that. I think there's one problem on here that is not correct. So we'll find that. Okay. And remember, you'll see STP a lot on this paper. STP. It gives us 2 pieces of information. it gives us a pressure is 1 atm. It's really convenient because this equation uses atm, so that's awesome. Temperature is 273 Kelvin. Remember those when you see STP, standard temperature and pressure. And you see that, look, number 4, standard pressure. So that tells you, right, PVNRT. P is standard pressure, so it's 1 atm. That's nice. And number 5 here, look, it says STP again, PVNRT. The STP is actually the really nice stuff because E automatically is 273 Kelvin, 273 Kelvin and 1 atm. And that's what's nice about STP. That's both standard temperature and pressure. On number 4, it only says standard pressure. It gave us a different temperature, so it's not standard temperature. Okay? So you plug into the equation. It's fairly simple to do. It's a simple equation here. And so, I don't think any of this is what. Let me look through these questions here. What volume would occupy? That's looking for volume. Okay. Sample of gas is unknown. That's standard temperature and pressure. So here's standard temperature and pressure again on number 7. What's the molecular mass? Oh, this one, number 7. Here's a hint on number 7. It wants molecular mass, so find the mole first and then convert to mass, and we've done that with a mini ed. Yeah, it's cool. Same thing here. What mass? So in order to find mass, you always have to find mole first. Okay. What pressure would require to contain that? Okay, that's pretty straightforward. What pressure? Okay. Sounds good. Sounds good. Oh, number 6. I just noticed number 6 here too. What volume would 22 grams of CO2? It gives you grams. And look, PV and RT, none of them has mass. So what can mass help us find if we know it's the mass of CO2? Mass can help you change to mole first. You need a certain number of mole of CO2 so that you can put that for N. Okay, this will give you your N. Alright, so if they give you grams, you can go to moles now. That's what we did when we did that mole conversions, just the last couple of units. Okay, so there's a little more work on this one, but again, these are just simple equations and you just plug it in. You don't have to memorize these equations. They're always going to be given to you. Okay, and so do that, finish that, and that's it for now, just for now. Bye-bye.